This is what the ring. The pink color circle, what you see, is a ring. As a very small gap. Are you looking at this? The dot where I'm pointing, a gap is there of length L very much less than R and carries a uniformly distributed charge Q. It's a positive charge. You can see from here. The ring is attached in free space and a uniform electric field E in the plane of the ring and parallel to gap is switched on as shown in figure. Find the maximum angular speed of the ring in subsequent motion. I think this entire, the whole diagram, I'm showing it here in this way. Okay, now this is a electric field E vector, E bar vector. Okay, this is a ring. Look at the gap. How the gap will be such a way that it will be directed along E bar. The gap will be parallel to E bar. I'm going to release from rest. Now tell me what will happen. Now definitely what I can say that the force, net force, it is made to rotate. Or you can say that the ring is hinged about O, so it can have only rotational motion. The ring can rotate about point O, about its center. Okay, fine. So that O is what? Let me indicate here. No, let's get into the this one. No, theta equals 0. This vertical line is what? Theta equals 0 degree. I'll define. Let me assume two elements, symmetric elements here. So what force is acting? The same force will act on this. So what about the torque? The net torque, in fact, will be 0 or non-zero. Yes, due to this element, it will be 0. Due to this part, what torque that will act due to this one? What torque that will act due to this arc? Equal and opposite will act due to this arc. This idea. So how do you can say? So we'll take elements. This is one element. So the torque by these two about O will be equal and opposite. Similarly, the torque by these two about point O will be equal and opposite. So therefore, the torque set up by electrostatic force due to charge on this arc about point O should be equal and opposite to this arc. So therefore, what all torque will be only due to the length of a ring that is equal to gap. So AB should be equal to CD. The net torque on the ring is only due to arc CD is telling. And what is length arc CD? Equal to the length of the gap. Arc length CD is equal to arc length of gap AB. This is very important. No. Okay, there's the initial part. Now what will happen to the ring finally? So the ring, what happens, starts rotating. Why do it rotate? Why do it rotate? Next question comes. What makes it to rotate? Okay, let's do one thing. There's a torque acting. So this F into this F into R small r, it will set up a torque about 0.2 in clockwise. So it will start rotating. Then the same arc length CD and the gap is here. These diagrams are very important. This is arc length. When the gap becomes vertical, the CD will be also vertical because AB and CD should be always opposite. Then now what I can say that the ring is having maximum angular velocity, because for this position it will have the torque will be decreasing, but the angular velocity will be keep on increasing. Now here in this position, the ring will have maximum angular velocity. Very next moment you come for this one. How the torque will be clockwise about 0.2, and how the omega was counterclockwise, so therefore the omega start decreasing. So what is the conclusion now? Theta omega increases. Then next, what we write here? Theta omega decreases. Agree this for theta greater than. So this what now that it starts decreasing because it will undergo retardation. No retardation. Or here only I'll write it. Angular acceleration. Angular retardation. Okay, it's asking that maximum angular velocity. We have to calculate that omega max. Okay, let me come to the sum. Okay, let me come to this position. Let me take the pointer. I can explain easily. Oh, where is the green color one? Yeah. Is it visible? Hello? Yeah, no. So talk about 0.2, about this point by this applied force. How much it should be equal to F cos theta, component of force. I'll take some other colors. Oh, where is that? Oh, yeah, I got it. Okay, F cos theta, F sin theta. So F cos theta into small r will be the torque. So what is the torque equal to now? Torque about 0.2 should be equal to I naught into alpha naught, mr square alpha naught. What is F? What is F? F should be equal to the electric field strength E by the charge present in the length CD. So lambda into L, because AB is equal to CD. Already I mentioned arc length is equal to arc length of the gap. So how much of charge present on the arc length CD should be equal to lambda L. So therefore F should be equal to Q into E. So what is Q? Lambda into L. So R gets eliminated. So we'll get this as alpha naught, where alpha naught is omega d omega by d theta dt equal to E lambda L mr cos theta. Let me simplify for omega d omega, E lambda L mr cos theta d theta dt d theta. So when do it will have maximum angular velocity? When theta becomes 90 degrees. So the limit will be 0 to pi by 2. Integral of cos theta will be sin theta. So this quantity will become 1. So maximum angular